Let's say that we want to approximate the soil modulus for a coarse layer. We could use a CPT-based set of formulations to do this. First, we start with this equation. The soil modulus is alpha E times the cone tip resistance minus the total stress. This is the total stress at a given point. What point should we pick? Mid-layer to represent the layer. This is the corrected cone tip resistance associated with the layer in question. And then this alpha E is a function of the IC parameter, which we use to classify soil. So the equation is 0.015 times 10 to the following exponent, 0.55 IC plus 1.68. This entire thing is the exponent. For coarse soil, sand and gravel, we could recognize that the IC ranges, let's say, between 1 and 1.3. Now, others may have a different selection of this range here, but I think this is reasonable for our approximation for coarse soil. And so what happens is this. If IC is equal to 1, which is this value, then alpha E is 2.55. And if IC is 1.3, which is that value, alpha E is 3.72. So a good number between these two to have in mind and to keep in memory would be 3. So if we go back to this equation, 3 times QT minus sigma V naught. But we recognize something else here. For coarse soils, the cone tip resistance is in the range of megapascals. 2 megapascals, 5, 10, 12 megapascals. It's very large, especially if the soil is at depth. This value, by contrast, is in kilopascals. So this value generally very small compared to this value. So we could say, we could remove this value from the equation, and so we have 3 QT. Approximation. These equations here, I obtained them from a book by Professor Robertson. Now, to continue a little bit more here, we could do the following. We could say, okay, this is great. Remember, this is a subscript. You could say, this is great, but I don't have a CPT. I don't have CPT data. However, I have the phi. For example, I have the phi of the soil in the layer. So in that case, you could use further correlations like this. 17.6 plus 11 log QT over square root of sigma prime V naught times little pa. This is atmospheric pressure, 100 kPa. This is the corrected cone tip resistance. This is the effective vertical stress in the middle of the layer in question. Okay? And so what do you do? Well, if you have the phi, you can use this equation to back calculate QT, so that then you can get the modulus like this. Remember, this is for coarse soil. And just to finish off here, this equation is called Howie and Main, 1990.